Hello and welcome to the channel. Previously I just made a video on how to make the data in using Python and OpenCV, and I'm being very late on making videos because of some technical issues. I had a very bad microphone, so I think this is going to sound much better. Alright, so let's just revisit what we have done in the last video. So very basic things. We will be simply going to just look for the what kind of device that we're going to use. First things, whether we're going to use the camera for the device, or I'm going to use something called the video feedback that can be used to capture the videos. All right, let me my previous video was very long, so I'm sorry for that. So I will try to make it as fast as possible, and I will also try to type as fast as possible so that I can make things. And the thing is that we are doing this real time, so it will be gonna take some time. So already we have made some images, and we have some unknown images, and we're gonna make the data set now. So we're gonna create something called a new file. Actually, I'm making this video once again. So we'll be using h5 dataset, h5 data.py. okay, create h5 data. Okay, so first things we'll import h5py. You might have to import OS, maybe OS sys cv2, and I think we will be using numpy as well. Yeah, obviously we'll be using numpy as np. All right, so our path is face images, right? So we'll be just setting our path to equals to face, capitalize there is images, capital images. So what are the number of classes that is there? So we will try to make a list or an array of classes. So we will have p for this is list comprehensions, okay, in os dot list directory and path. So that's the thing. So we're going to go to this, it will be in. All right, so we're going to go to this, and we're going to select all the folders, and whichever the folders are there, the name of the folders will be made as a list. So we will be having something like quickly I will just show some like Nirban and this is the class that we're going to have. Okay, so let us go back. Yeah, we could have like used this as a comment just to know how it looks like. All right, so we'll be having the data is equals to something like this. So this is our data. So we will quickly try to make this data how it's going to look like. So we will be using for I. We enumerate all the classes. Basically, for every classes we will be searching for the images, and we will be inserting into data file. See the class in enumerate classes. Okay, so new path will be equals to path. It will be we'll be using a list joining this as a string. My right arrow is not working, I don't know why. Here I'm always having some kind of new path is equals to, we'll have a list again, we'll call it as list. It will be like new path plus again it will be / and p again, so for p in os dot list directories of new path. Okay, so it's gonna have all the images in this. Okay, so new path is gonna have all the path or image path basically. So now for p in new path, so okay, so im is image is equals to cv2.im read. I think yes, it's going to be im read, and that file p. Okay, so p is nothing but the path here. for absolute path or whatever it is. So we're gonna make it as a tuple equals to I. It's gonna make it like image and the ith, for which class we are doing it. Yes, okay. And we're gonna use something called data dot append append, and we'll be appending that tuple. That's it. This is the basic thing. Now we're gonna use supervised learning, obviously, because for that reason we'll be using this x and y variable, the most important thing. So we'll be creating the ground truth. So I hope I am running with time, I don't know. Anyway, so for I in range, I think you will do it range, length of data. Okay, so what I will do is here im comma y, this is the thing, equals to data as I. That's it. So we're gonna have the image and the class, what class it belongs to. Okay, so the x dot a append will be image, and y dot append will be it's an array of y. That's it. I think this is more than enough. Now the second most important thing is we should convert this as a numpy array. Numpy array x. God, my right arrow key is gone, I think. Numpy array y. Yes, okay. So we'll quickly just print the shape and everything so that we can see that everything is going correct or not. Print shape will be x dot shape, print y dot shape. Okay, all right. So we'll be making a numpy classes, np classes equals to np dot array, it will be classes, and the data type will be d type is equals to numpy dot string ing didn't happen underscore. Yes, this will work out. Yeah, okay. So print np classes. Yes, I just also see everything is fine or not. So now we will try to create the most important part here is we will try to make the main data file. So we will be using the HDFS system with h5py dot file. So we will create the data set here. So data set is there. Okay, so we are having some kind of error, I don't know. Okay, anyway, we'll see it later. So data set face images, okay, face images dot h5, okay, and we will be writing into it as file. So f dot create dataset, we will be naming as xtrain data is equals to x, and I think max shape is gonna be something like none 64 cross 64 cross 3, because 64 cross 64 images we are doing, and I think it's going to be data type, dt type is equals to int. That is, I think, more than enough. And we're gonna do f dot create data set. We're gonna have the y train values underscore y train. This is gonna make kind of dictionary actually, but it's stored in a file. People sometimes use pickle for that. Y and the max shape, max max shape is not showing us here anyway. None comma 1. It is going to be data type as dt type is equals to int. Again f dot create dataset classes. What are the classes that we have? Name of the classes, data equals to np classes, and it is like max shape, maximum size, max shape is equals to we're gonna have it like none means actually we can have any number of data type. So and it's gonna be dt type, we're gonna be h5py dot spatial data type vlen equals to, I think it's going to be str. That's it. I think this is the thing that we're going to do for it. So let's see if this function is working fine or not. Okay, so we will quickly run this. I hope I don't get any error. Very good. We have, I think, created the dataset successfully. So I have created a test file here. This test file, face images, right? Face images, yes. So I'm going to read this test file now. Let's see if I'm going to get the image that we are going to have or not. So come on. Okay, we have got some unknown images here. No, this is an unknown image. It shows something like that. Okay, so again, if I show, okay, so if I can make a random number here, okay, x train, y train, next train would be, I will make some random number. I was saying numpy is there, right? Why am I using it? I is equals to np dot random dot randint. I will say like 10 to 100. I don't know how many are there. Basically we have 164 images. Oh, more than enough. So I will use I here. So every time I'm going to get some random images whenever I run it. Yes, again if I run it, again if I run it, I get the same images. Why? Okay, I'm getting some unknown images here. So I don't know, I played some movie and I just made some images like that. Okay, all right. So so far so good. So next we will create the neural network and the structure of a neural network. You will be using object-oriented programming and techniques. We can basically do the same thing using TensorFlow within 5 to 10 lines, but I don't want to go through that process. Okay, so far so good. So we will meet in the next video.